I'd like to talk about two concepts in memory. Let's start with something called the stack. This is the stack. Whenever you have a block of code, everything that happens inside of that block of code is put on the stack. So let's say I wanted to create an integer I that's equal to 42. This primitive is put on the bottom of the stack. Let's say I then call into another method, and in that method it wants to deal with something. Well, here's another primitive, this Boolean. Now, if we're all in the same block of code, we all share the same stack. If we're calling to a different method, we don't have the same stack. Each method has its own stack, and it's a very efficient way to deal with these primitives. What happens if you want something more complex? For instance, an object, like so. Well, stack isn't really good for objects. They're too big. They're too complex. Stack is designed for dealing with primitives. So then how do I actually deal with an object on a stack? Well, let's say I have object, my object. I can put a pointer on the stack. Technically, that's still a primitive. But I'm going to need to deal with a different type of structure of memory in order to actually use that at all. So that little guy is going to point to this object I'm going to describe right now. Just write object on this card. And think of this little section of memory as being a part of something else. If it were arranged like this, as a stack, it'd be really easy to go through. But unfortunately, you can think of the rest of memory that isn't in your local stack as kind of being like this. That's why we call it the heap. In fact, in order to deal with the heap, you have a pointer, and when you set it equal to something, you kind of have to go through here and find a space to allocate it, and then put it there. And yeah, it will point there, but it's a very slow process. Primitives on the stack are very fast, but these things are much slower. In fact, we have to go through them one bit at a time in order to find anything. So again, this concept of a stack is incredibly fast. When my method is done, I can just take the stack and have a new one. However, the heap works a little differently, right? We were talking about garbage collection. Now, what garbage collection does is it has to actually go through the heap and find things that no longer have a reference anymore. And it's the one that decides whether or not that memory can be freed and allocated for something different. So with these two concepts in mind of stack and heap, heap and stack, you can put most of your efficient code locally in a block and use the stack to your advantage. And save the heap for situations where only you need state to stay around. And now you know the difference between stack and heap.